Next slide. Alrighty, well, good morning, everyone. My name is Ixel Torres. I'm with 3CRN. Thank you for joining us. Before we get started with detailing for high performance roofs and walls with Jennifer Rennick and Andy Pease from Imbalance Green Consulting today, I just wanted to walk you through some intro slides and get you just introduced to 3CRN a little bit. Next slide, please. So I know we are all pretty familiar with Zoom, but we ask that everybody make sure they are on mute throughout the duration of the course. If you would like to verbally participate during the course, we please ask that you raise your hand in the participant section and we will call on you to mute yourself. We encourage you to participate and ask questions through the chat box as well. Next slide, please. A few words about who we are. We are the Tri-County Regional Energy Network. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3CRN is funded by ratepayer dollars, which are collected through the public goods charge found in our utility bills. Next slide, please. Currently have 3 programs. Our first one being the Energy Code Connect program, which serves building professionals by offering trainings and support to make energy code easier to follow. Within the Energy Code Connect program, we offer Energy Code Coach service and over the phone, online, and in the field support for Title 24 Part 6 and Part 11 related questions for both residential and non-residential projects. We also offer online courses and regional forums that are designed to increase overall energy code comprehension, compliance, and enforcement. Next slide, please. Another program we offer is Building Performance Training, which serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skills trainings related to building science principles and high performance buildings. Next slide, please. And our last program is our home energy savings program, where this program offers and incentivizes contractors and helps residents to save money and makes their home healthier with energy efficient upgrades through incentives and rebates. And with that, I'll hand it over to Jennifer and Andy to get us started with our presentation today. Thank you.
Great. Good morning. Thank you so much for attending today. Thank you to 3CRN for hosting. We have a wonderful partnership where we're able to bring classes to the community at no cost due to these ratepayer funds. So today's learning objectives, these do meet the Health, Safety, Welfare, AIA continuing education, as well as ICC. And what we're looking at today is about the envelope and detailing. And we talk about this all the time in higher performance and being able to have strategies for code compliance. And so that is what we are going after today. Next slide. So our agenda, Jennifer is going to be delivering the entire presentation. I'm here more decoration. I'm going to be monitoring the chat. And we are recording everybody. The recording will be broadly available to everyone. And we're also going to send you the slides. So you can relax that you'll have access to all of these. It's just 1 hour, so we're going to move pretty quickly. I'll check in with the chat, see what I can answer, quick answers at the end. But at 11 o'clock, then Jennifer will be able to stay on. So if you do have specific questions on detailing or special circumstances or any of that kind of thing, stick around and you get that free resource to be able to coach on those things. So, and just as a reminder, where this is coming from is these big picture goals in the 2022 Energy Code, about electrification, about, of course, energy efficiency, also about ventilation and indoor air quality. And with that, I will turn it over to Jennifer. Thanks, everyone.
Thanks, everyone. I'm glad you could join us. Yeah, like Andy said, or Itzel said, yeah, feel free to put some questions in the chat, and then Andy can stop me and ask the question. We can take care of it as we go. Before we get kind of started with talking about our walls and our roof assemblies, and those are the ones specifically we wanted to hit on today, a kind of big picture is that I'm approaching this from the perspective that our 2022 energy code and our residential code is pretty darn good right now. And so if you build to those prescriptive standards, you will, and if you follow the mandatory measures, you're going to have some high performance assemblies already. So what we wanted to do today was review some of the detailing and just some of the places that we're noticing, like in the field, that maybe are not being executed as well as they could be. And some of that pushback we're getting, then this is via our HERS raters are saying, hey, a lot of these folks are saying that these better ways of doing things are not on the drawings. They're not they're not showing up on the architectural set. And so that's why we're kind of approaching this as, yes, it's also part of code, but it's also a high performance assembly. So we really want to talk about both. So a few key terms. Air leakage. By air leakage, I mean the uncontrolled air movement through building assemblies. It's like the uncontrolled movement. It could also be air leakage with ductworks, for example. Infiltration, leakage from the outdoors in. Exfiltration, leakage from indoors, outdoors. In both cases, those are types of air leakage that's coming through your building assemblies or your HVAC ductwork. Vapor, as a reminder, when I use the term vapor, I'm talking about water in its gaseous state. And when I talk about condensation or water condensing, I mean that vapor is condensing to liquid water. And when we say moisture, it's still liquid water at that point. And then as a reminder, there is capillary action of water. So water does move through porous materials, through adhesion, cohesion, surface tension, and up through membranes or materials that are touching, but maybe aren't sealed together. So that can pull water into an assembly. Air barriers, we're going to define that. Thermal barrier, I mean that part of our envelope that controls heat transfer through a material. And by rain screen, I mean the outer layer of a wall assembly that is the cladding that's usually used to control rainwater and allow for water drainage behind the cladding if necessary and easy drying. And then 3 key things to remember is that vapor, so water in its gaseous state, those small molecules, it turns out it's more buoyant than the air, than what we consider air. And warm air is more buoyant than cool air. And also warm air can hold more moisture, hold more vapor than cool air. Okay. There are a few standard definitions that I wanted to remind folks, because in some of these details and some of the code language, it's specifically mentioned that, hey, you need to use a class 1 vapor barrier. And so by vapor barrier, we mean a material that has a very low permanence. So 0.1 perm or less. And then otherwise, we often call them vapor retarders. And then something that is vapor permeable, so it allows vapor to pass through it more easily, we call that like vapor open or vapor permeable, and it's measured at being greater than 10 perms. And then as a reminder, air impermeable materials and air permeable materials have different measurement. but we're going to refer to those materials specifically when we talk about insulation types and some of the roofing details. And that matters because the material that allows air to pass through it may or may not allow vapor to pass through it. And it's possible to have materials that can allow vapor to pass through it one direction, but not the other, and to stop air movement as well.
And Jennifer,
So,
going through
yeah.
all of that as a reminder, because those are the kinds of questions I ask. Like, wait a minute, what are we doing with the air permeable membranes, et cetera? So now everybody has a baseline and a resource. Thank you, Jennifer.
And it's a reminder, right? Okay, so okay, oh, let's see. Back up.
No, you're good.
Audience?
Keep on. Keep going.
Okay. So thermal boundary. Okay, so a really good resource. I think this is a good resource to maybe talk to your clients. If you're going to talk to your clients about this, energy.gov, Energy Saver, they've got this diagram here that kind of points out examples of where to insulate our building and how to create a continuous thermal boundary. And then I would just add that for a lot of the high performance attics or semi-conditioned attics, that we're going to be looking at also insulation, continuous insulation that's up at the roof deck itself. And we expect our buildings to keep us warm and dry and comfortable, and to not use a lot of energy to do it. And then our air and moisture barriers, again, same resource. We're a good diagram for looking at where there are trouble spots for air sealing. And these are classic spots. And we're going to hit on a few of those in the presentation today, but not all of them, because we, Andy said we only have an hour. We're going to add to this list, though. So my notes is to add the green is to also include under slab membrane and waterproofing at that ground level as well. And air sealing is part of the energy code, but that is a place where we see that a lot of folks are not actually implementing the energy code, even though that is a key component to a high performance assembly. So with that, I'm gonna hit kind of from bottom of the wall up and just hit on a few key elements of a high performance wall or high performance assembly. And so base of the wall, foundation to vapor barrier in a raised floor situation, for example, getting what is happening at the bottom of your building is going to very much impact how the rest of the building performs because of moisture that's in the soil or radon that's in the soil, which is present in a lot of Santa Barbara County. And so this particular product was on a job site that we worked on for a multifamily housing project with a raised floor. And this the Stego Wrap, and there's other brands out there. We just happen to use this one as a class one that's a vapor barrier. And the key thing here is that the membrane itself is taped and sealed. So all the sheets are continuous, and then the membrane is securely attached to the foundation. And I just want to point out that a lot of the manufacturers now of building materials are offering extensive online help and resources for architects and builders to really detail out the projects. And then they have a line of materials that go together so that you can execute the job and know that these materials are chemically compatible and meant to go together. So we're seeing that drawings or details that talk about this are not necessarily on a lot of drawings. And some of that pushback is the builders are saying, well, it wasn't on the drawing set. And so it becomes usually a change order and cost increase. For under the slab, if you have a slab on grade, the American Concrete Institute recommends a 10 millimeter minimum vapor barrier, so that class 1 vapor barrier. And it calls for the concrete to be placed directly on that vapor barrier, which I've noticed in California and even in around our area, a lot of times it's not detailed on the drawings, or the architect has drawn, or the structural engineer has drawn a detail where it calls for sand over gravel with vapor barrier and then more sand on top of the vapor barrier. And I just want to point out that that's kind of an old way of doing it. So if you haven't updated your detail on that slab, I recommend you do it, and to show what you need to do without the sand. And how this material is joined to make this continuous vapor barrier, both under your slab or under a crawl space, is if you have situations where you've got a grade beam, you can either put that material on, follow the ground and actually scoop it under the grade beam, or in this photo, you can add mastic, one that's compatible with the under slab barrier, and you can stick it to that grade beam and stick it around the rebar, and then pour the rest of the concrete on top of that directly. So we are assuming now we've got a good foundation and a good slab, both raised floor. So now that crawl space or that slab on grade is going to stop moisture from moving up through the house, through the floor assembly. So, okay, that part's taken care of. Now we get to the wall assembly itself and kind of look at what makes a high performance wall assembly. California Energy Code, prescriptively residential, it calls for exterior continuous insulation on our wall assemblies. However, there, in a lot of our milder climates, there's opportunities to use a performance method modeling and to not have to use that continuous exterior insulation. But it definitely is going to improve your building. And over the years, seems like I'm seeing a lot of folks migrate towards a system where you have your stud, your structural sheathing, then your house wrap or membrane, which is able to allow vapor to pass through it out of the house and dry, and then the continuous exterior insulation, and then create a rain screen, which is essentially, in this case, strips of plywood that creates a 3-inch gap behind your siding material. And that, in essence, is like this high performance wall assembly. And you can think of it as in layers. A very good example, and one of the builders, Mike Horgan, that we work with, really likes this line of products that's offered through 475, and they have a three-dimensional drawing of the system that they're talking about. And in this case, the self-adhering membrane is that primary air barrier, and then the insulation on the outside continues with the thermal envelope, and then the wall assembly, the rain screen, is layered after that for bulk water control. And I just wanted to point out that there's really more than one way to do it, but conceptually that follows a pattern. And depending on what line of products you like or what brands you like to use, we're seeing that more and more of the companies are offering architectural detailing, really detailed details. for their products that you can rely on, and they've been vetting these materials. So for example, for that exterior insulation, if you're going to use rock wool instead of Gutex, which was shown, you could go to rockwool.com and they've got great details to show how to use their product with a rain screen, including using it with stucco. And if you're a big fan of Zip System, they've got details for their rain screen, also with exterior insulation and how to do that with stucco. And then Coravent is known for ridge vent and E-vents, but they're also making now products that can be used to help stop insects from getting in behind that rain screen. And so they have detailed how to use some of their products in your rain screen wall application. And that's just a few of them. There's Delta Dorkin as well. We'll look at that for a window. And Tyvek has their whole line. They're all getting on board with this, is what I'm saying. So really, you can do a high performance wall assembly, is what I'm saying. It's within your reach. So part of that wall to foundation airtightness, and the reason I'm bringing this up is because it turns out that we can build a high performance wall assembly with that exterior rigid insulation and layer it up. And as architects do, we could put that in the drawing and then we think we're good. But really what happens when you get in the field is it depends on the builder and it depends on those drawings. Is the whole system going to perform as an enclosure the way we want it to? And if the building leaks a lot of air, both through infiltration and exfiltration, you're not going to get the high performance that you were counting on or your homeowner is counting on. And so it's important to look at how these air connections from our wall to our foundation are airtight. And in some cases, the membrane is itself sealed to the foundation just below the structural sheathing. And in other cases, with like the Tyvek system, there's straight flash flexible tape that can be used, and there's puttied on liquid applied membranes as well. And then how that, might look in drawing form, and also to really call out is your structural sheathing. Where does it land relative to your sill plate? There's a lot of options for how to do this. And this is where some of the individual way that you as an architect or designer or builder want to sort of piece this together. But I will say that if I think you're going to be building in a situation where the plywood or your exterior structural sheathing does come long past the sill plate, then you do want to use a tape or a membrane to separate that sheathing from the concrete. And then otherwise, if your sheathing is being held up off the concrete or flush with the concrete, then you can use a liquid applied membranes. But there's also kind of the old school, which is using continuous beads of caulk and sealant at the sill plate, and then doing the same thing on the interior sill plate prior to drywall. And this photo from the left is just from a recent job that we were taking a look at, and they did that method and it worked beautifully. And it had a very good QII and blower door test with it. And you can also use continuous gaskets between the sill and the foundation plate. Our HERS rater says they aren't seeing this as much, but I just came from a job site last month that used this continuous sill gasket, and it seemed to work beautifully for them, and it comes in rolls, and this is part of the Tyvek Owens Corning's product line, but there's other makers out there.
Hey, Jennifer, before we go to that next section, I wonder if we can give kind of a quick point of discussion about cost. Someone's asking about the cost analyses of these different assemblies, including labor involved. And I remember, you know, kind of that big picture conversation about the, you know, perhaps an extra day or two in the field, but it otherwise goes pretty quickly. But I know that project that we were looking at, that Mike Horgan did, that it was so well air sealed that there was a cost savings because there was only one small heat pump that did all of the heating and the cooling. And so there was a cost savings offset there. And because of that savings, the zero net energy offset of the PVs was, I think he only had 16 solar panels on the roof on that one. So I don't have, you know, Mike would be able to speak a little bit better to the additional time, but I think it's the whole envelope conversation, and then the you know, the ripple effect from there. I don't know if you have anything to add, but I just wanted to jump in on that.
Oh, that's great. Yeah, you're right. Yeah, that's part of it. And so I guess the reason a lot of this for, you know, air quotes, high performance walls and roofs is, yeah, like a few years back, we were talking about just get that exterior insulation on your walls. It's high performance, you know, but folks who are really in the field and doing it, they're like, yeah, but you can't forget about the air sealing, because if there's a lot of leakage, your performance is going to plummet from what you really expect it to be. So that's kind of where the loose gaps are. Now, California Title 24, the energy code doesn't explicitly require blower door tests, but it does explicitly, as a mandatory measure for a long time now, has said that, and it's up at the top of the slide here on the left, that all joints, penetrations, other openings in the building envelope that are potential sources of air leakage shall be caulked, gasketed, weather stripped, or otherwise sealed to limit infiltration and exfiltration. And so that's where we're just seeing the weak links are. Windows themselves are even rated for air infiltration. And when it comes to your windows, this is kind of a typical way of doing it, what you might see during construction, where that house wrap from the outside wraps in the sill, and then a continuous like peel and stick flashing tape is used at the bottom and lapped up on the sides, and then all the small gaps are air sealed with foam. And there are great resources available for how to show that on your drawings or how to detail it. And I know some of the architects we work with have just started, if they know sort of what swim lane they're going to be in, with what product line they're in, they're just referencing those details directly in their drawing set that just lays out the assembly of how to do it. And again, it's because in the field, there's some pushback saying, oh, well, it wasn't in the drawings that I should do it this way. And then Dorkin, Delta Dorkin, they've been detailing, giving folks drawings of how to flash and how to use a bug screen. And you know, again, like Core Event makes screening as well, and how to set that up for exterior continuous insulation, and their products line for doing stucco, and what that looks like for a window that has a thicker wall assembly, for example. And then also there's resources out there for how to add diverters at window heads to make sure that that water doesn't just drip down into that thickened wall look on the outside of your house. And kind of like full circle, QII, quality insulation installation, is now a requirement for prescriptive pathway for residential construction. It used to be that we could click or check QII as a credit. and that credit has gone away. You can choose not to do QII and run it under the performance method and take a penalty for it. But what we're finding is that a lot of projects are just now having QII as part of it. And the HERS rater that we work with has been going out to a lot of job sites and seeing that folks really haven't been air sealing and haven't really been following the QII protocols. So I'm going to have a few slides here where I've just pulled information from the forms that a HERS rater would use. And the reason I did that is because it's also a great resource for architects to go and pull these forms yourself and grab parts of it and use it in your notes and have it on your plan set so that everyone in the job site knows that they are going to be doing air sealing. It's part of the scope of work. And here's just some good examples of what that can look like and some of the advantages of using like the self-adhered membrane, for example, in that picture on the left, where plumbing vent piping is coming through the sill plate and that self-adhered membrane is still intact, or you've got sewage waste piping going down, same thing. And then whenever you have penetrations through your wall assemblies, such as your roof rafters, there are specialized tapes now that can be used to tape around each rafter so that doesn't become a big hole and air leak in your envelope. And then, of course, there's foam sealant products that can be used for piping penetrations in your wall. And kind of along the same lines as that, you can add these notes. It's in the blue highlighted area that you want to just remind folks that they should encapsulate their electrical boxes and cut around the electric boxes. And if you're using a batt insulation type, it should be delaminated. And then so half of it behind the wires and the other half in front of the wires. And if they do a good job, then it should look really beautiful, like the picture on the left. And in contrast, this is kind of the picture on the right is typically what we see. So again, I recommend maybe explicitly saying that there's not to be any voids and gaps or compression in your insulation. But as an architect, you can spec out blown-in products and start there because you will automatically not have any of the gaps and any of the issues that you would have with the batt products.
Hey, Jennifer.
Yeah.
I love these notes that, I think of, it's my favorite hack for being able to get the information onto the plans. And we had a question about what's the best way to access these forms. And I was thinking when we send out the PDF that we could just drop in the links either to CEC or probably Energy Code ACE would be the easiest way.
Oh, it's okay. Yes. Sorry. I meant to put that on there. It's CEC, California Energy Commission forms, residential forms. And we can also send a link because you might automatically get linked to the 2019 residential forms when you do a Google search. Just click that anyway. And then once you get there, you can back out to get to the 2022 forms.
Great. And it looks like Jen was kind enough to drop in a link to direct to the forms, and then the number of the forms is on each of these slides. So
yes,
giving
thank you.
A few resources. Thank you.
Thank you. Yes. And so I think you're right. I think it's a great hack, as you put it, is to just they're informational. They're going to have the official watermark when the HERS Rater comes out. But as an architect, designer, builder, it's great. You can use these and just pull the notes off of them directly without having to go through pages of codes and the reference appendices, etc. Another big spot we see that often has a failure point is the tub and shower enclosures. This just comes up time and time again, and it's kind of a big deal, even in interior walls, when you're talking about stopping air movement and airflow from one space and room up into attics, if that interior wall has not been sealed or capped at the top. But especially for exterior walls, there's supposed to be a continuous air and thermal boundary before that tub or shower enclosure is installed. So that means you're going to have a tape and sealed MMR, or moisture, mildew, mold resistant rigid air barrier that's taped and sealed, and then install that shower and bathtub enclosure. So kind of from the architect's perspective, what I've been starting to do or to look at is, if I know, for example, I'm going to have a tub dimension, and let's say it's a standard, so it's 60 inches, then I'm going to add, 1¼ inches to that length. So it's on there for the framer to allow for that extra space to get that air barrier in there. And the material, you can use 1/2 inch, but 5/8 inch is common, and no one's going to be mad if there's a little extra room to work with. These notes that I put below that plan is from the Build America program. So it's part of our government resources, and they have a number of guides and sort of best practices, and they include a whole section on tub and shower enclosures. And what our HERS Rater Paul Dunn sees a lot is, oh shoot, we couldn't fit, we didn't have enough room for the air barrier, and we didn't get the sequencing done properly. We didn't get it in place before we set the tub. So can we just slide some Tyvek back there? And Paul says that's not an approved air barrier material in this application. So anyways, there's another one of those hacks, like to put this stuff on your drawing so that when, you got your high performance wall, but now you have the high performance entire enclosure. Okay. With that, I'm going to move on to roofs, both vented and unvented attic assemblies, and some trouble spots also that show up as far as air barriers and air sealing. So mandatory measure now for 2022 Energy Code, prescriptively, as well as the prescriptive requirement is you've got insulation at your ceiling, and you also would have insulation up at the roof deck for certain climate zones. Okay, and that implies that it's like an R19 under the roof deck, or a performance method, you could have an R5 continuous exterior insulation. And what we see now with other assemblies, you can do these other assemblies. You can use the performance method for it, but a lot of these assemblies depend on understanding whether the roof rafter area is going to be vented or not, and whether you're trying to achieve an unvented attic with continuous air and thermal barrier, or if you are using a air permeable insulation, because a lot of folks are trying to move away from foam. At least this is a lot of the Code Coach questions we're getting. And they're not finding any direction in the energy code. And that's because it's in the residential code. So kind of slow sidebar, I want to just kind of give you an idea that your energy consultant, what they're looking for these high performance attributes is they want to know whether that attic is vented or unvented, whether there's a heel height at the truss and how high, because that determines how well the edge of your house is being insulated, and whether that insulation covers the framing at the underside of the roof deck. And then they're going to be looking at the total R value with and without framing, both for interior insulation, cavity insulation, and exterior above roof deck insulation. And whether or not maybe you are using a spray foam product that does require the QII just for the spray foam itself. So these issues that come up with these different combinations of insulation materials, and whether the attic is vented and whether it has vapor diffusion ports, all those are regulated in the Residential Energy Code. So Title 24, Part 2.5. So you're going to want to reference Section 806.5. And specifically for our climate zones, there are ways to use air impermeable insulation, but you will need to have a way to let the vapor that's more buoyant than air that can pass through drywall ceilings, even though that drywall can act as your air barrier, the vapor can go through that assembly. That vapor can hit your roof deck and it can condense. And that's where we get a lot of the mold, structural sheathing rot, and mildew problems. And when you go take a look at this part of the code, I threw the slide in here just to give you a quick reference that it's going to mention certain climate zones, and we're in climate zone 3C when it comes to the international code. SLO County, Santa Barbara County, Ventura County, that's our area. And an R5, air impermeable insulation, is kind of what's required as the base code. And another, I just threw this in here, so a quick reference, it lists our climate zone 3 by county. So if you're in a different county, you can also look it up. It's in a different section of the Residential Code, Chapter 7, but it's in your slide deck, so you can have it. So for unvented rafter roof assemblies, you can easily do blown in over spray foam. And here we go with the difference between air impermeable and air permeable insulation. 2 inches of closed cell spray foam is needed to count as air impermeable insulation. So a lot of times you'll see that amount of spray foam insulation, then the rest is cavity filled. And this is all about condensation control and vapor control and air control through our building assemblies. So this would be part of a high performing roof assembly. Another way this might look, and this was on a recent job that our HERS rater was at, they did the spray and foam, and then they put in fiberglass bat insulation, and we'll put the drywall up there. And again, I clipped out part of the forms that the HERS rater uses so that you could get the verbiage for how much of closed cell foam and how much of open cell foam is needed to count as an air barrier. And for the detailing, yeah.
Oh, well, I was just going to kind of check in big picture, just as a reminder that part of this is about thermal, just in terms of the vented versus unvented, that kind of improved thermal performance, but also the layers of fire prevention, right? That we don't want those open vents. Are there other kind of big picture reasons why we are seeing so much of this unvented options or leaning toward?
Oh yeah, that's a really great question. A lot of it has to do with fire wired wildland interface where folks are not wanting, we are getting clients who do not want to vent their attics. They don't want to take a chance of having that open. And also in some of these instances, like these drawings, it leaves your attic free and clear to easily do recessed lighting and all your wiring, and really easy place to do a horizontal ducted air handler unit if you want it. And there's a lot of reasons why folks are wanting to do that and keep it unvented.
And can you do a roof with just the rigid insulation on top of the sheathing, or do you also have to have, you know, in terms of like if you were doing a cathedral with exposed beams, can you meet all of your thermal requirements with a rigid above?
You can. Yes, you
Okay.
can. I didn't show that because we don't see it that often, and it's the most expensive way to do it, but you certainly can do it.
Right. And then you're just looking at the R value that's required in terms of the thickness of that insulation, I would imagine.
Yes, and it does
Yeah.
have to be a certain amount, and then that's also sort of kind of spelled out in the residential code as far as making sure that any vapor that comes up through the drywall, because drywall it's vapor permeable around 24 to 35-ish, 40-ish perms, which is really, it will stop the air when it's taped, sealed, painted, but it'll definitely let vapor through it. And then it's buoyant. So all that vapor is eventually going to collect up at the peak of your attic. So another reason to maybe consider this, and then we'll look at that other kind of assembly real quick, is that there's something called a variable capacity heat pump compliance credit option, where we're seeing the projects get a lot of Title 24 credit, a lot. And so now, as part of that requirement, if you work with your energy consultant to do that, you're going to do heat pumps, mini split, ductless units, for example, but they don't like the look of it on the wall. They want to have it recessed in the ceiling. These kind of assemblies are great because you have a free and open assembly. But if you're going to insulate on the attic floor, that's okay too, but you have to know that you're going to have to do a detail for how you're going to tape and seal and maybe drywall or buy a pre-made unit that fits over that, so that that ductless unit is completely within the air and thermal boundary. And that's a mandatory requirement of getting that credit. Now, let's say, you're not going to do that, but you want the open ceiling look and you want it clean, but you want to just go ahead and vent it all. You don't want to deal with the foam. There is a way to do that. And this is for one of Mike Horrigan's jobs, where an vapor open permeable membrane, it stops air from coming into the house, but it allows vapor to get out of the house. And they're basically setting up sleepers over the top of the framing, the roof framing, and allowing continuous airflow for vapor, but still maintaining the integrity of the thermal envelope and the moisture and air barrier. Now, you're not a big fan of foam, but you still want to do like one of these kind of options, and you're going for that variable heat capacity credit, for example. That's perfectly fine. And then but you have to do some specialized detailing. And so, for example, if you're going to have an unvented attic with that air permeable insulation at the roof, so not foam in this case, you actually need to produce a little bit of supply air into that attic. So it's unvented in a traditional sense, but it doesn't mean it's not unconditioned. It's actually semi-conditioned, and that's okay because it's all inside. Your attic is part of your overall thermal envelope. So it's perfectly fine. And I included the verbiage out of the code for you to take a look at. And then I included kind of a diagram of what you would need to do for what's called a vapor port. And this is just one way to do it. And you do have to calculate that vapor port area just like you would calculate your ridge vent openings that you traditionally do for a vented attic. And it's essentially the same calculation. And you also a calculation for how much supply air is required. And so that a rule of thumb is you need about a 6-inch diameter duct per each 1,000 square feet of ceiling area that would bring 50 CFM to that space. And the vapor ports, you can, to be vapor open per the residential code would be a material that's greater than 20 perms. And so there's a lot of vapor open membranes like the one we just saw in that other roof. And that can be used, you can use a non-vapor open membrane on your roof deck. That's part of your bulk water and waterproofing. And then you can use that vapor open membrane where you actually have the holes and the penetrations up at the top. And what that kind of could look like also is if you need a fireproof assembly, you can use an exterior gypsum sheathing product that's fiberglass reinforced that's meant for that exterior exposure, and it's greater than 20 perms. And so you can create a typical standard ridge vent assembly with that and have your air permeable insulation at your ceiling level, for example. And this is like a photo up in a recent attic that Andy and I were in, and they had a kind of standard ridge vents that were open to the outdoors. So it would look like this. You would detail it the same way, except instead of it just being open, it would either have that vapor membrane or like the exterior gypsum sheathing as part of a more fireproof assembly. And this is just one way to do it. You can also have just like vapor ports that are concentrated that look like mushroom caps periodically in your attic as well. But this I think is cleaner and seems to fit the more custom residential look. Kind of big picture part of all this too is that you could do all this great work for that high performance attic roof assembly, but what Paul sees all the time again is the air sealing is forgotten. And as a HERS rater, when he goes out there, he'll take the grills off the supply and return registers and take a look, and he'll often see that the drywall was never caulked to the boot for the air handler. Or if you're creating a special case to go over your lighting or those recessed ductless units, and then put the grill on it or the cover, like that gap. And fans, same thing, that gap between those units and the drywall is often missing. So he'll pack up and say, no, finish the job, then I'll come back, because he knows it's going to be an automatic fail. And so here again, I clipped in for you that air infiltration sealing kind of at the framing stage. So you can include that on your notes or include something about it. And then a close akin to that is getting a great credit for, say, ducts in conditioned space. Kind of goes back to that variable capacity heat performance credit. If you're using a high performance heat pump, but your clients want a ducted system, and you can get all that ducts within the conditioned space, and you're wanting to have a more traditional attic, or your insulation is on the attic floor, then you're going to create ducts typically in the soffit And so there's a sequencing and a staging that needs to take place. But I think for the architects, what you need to look at is if there's enough space to make sure that they can get a drywall tape ceiling for a continuous air barrier, because that soffit's going to need a lid at the ceiling. So you will undo everything that you have tried to do if the builder gets out there and creates a soffit and only drywalls the outer edges or the edges of the soffit that face your interior and leave that soffit open to communicate freely with the attic. Then all your duct leakage goes back into the attic, et cetera, and we're you kind of just undid it. So it's an opportunity, really. And then really last thing is I would be amiss if I didn't mention outside air ventilation situation, because we're making now our envelope, the floor, the walls around the windows, all the penetrations, the ceiling or the roof and its penetrations, everything is now tight. We are trying to control infiltration and exfiltration and reduce vapor migration to the peak of that attic that causes condensation rot. We've done everything perfectly. Now we have this very tight, sealed up house, and we're going to have outside air as part of the code requirement, but also just for comfort. And if you use an exhaust only system, which is pretty typical, you're just negatively pressurizing the inside of the house and inducing unnecessarily infiltration through any crack, any place the air can come through. So what we recommend is balanced ventilation. And then a step up from that is an HRV, where there's actual like heat transfer from the outgoing air and the incoming air. And there's many systems out there now, and they, in order to get credit on your Title 24, they do need to be certified. And you can find that on the CEC website. And just to give you an idea of what that can look like for individual dwelling units, it doesn't have to be as a complicated ducting system as thorough as a Zehnder, for example, or Renzar also makes it. It can be more straightforward, like this HRV that was inside a closet in a multifamily dwelling, where each individual dwelling had this rinse and air product that allowed fresh inside air to ventilate. And then last but not least, we recommend that you put on your drawing set, right? Maybe on the first page, just to remind folks that, hey, this project requires QII and air sealing, or equipment verifications needed, or you're going after that VCHP credit. And point it out and include notes in your drawing set to approve it. And if you do that, you're going to work with your consultant for the consistency, and you'll make your friendly HERS or rater happy, and your friendly energy analyst happy, and your clients hopefully very happy. And with that, call us at the Code Coach service. We're available. I could stay on for extra few minutes. I'm sure Andy's got to run, and Itzel can tell you a little bit about the upcoming projects. And thank you so much, everyone.
Thank you, Jennifer. And before I let Itzel go over the closing, I do want to just say that this was a newer presentation for us. It's based on kind of a lot of conversations we've been having over the years. So if you have suggestions, want other things detailed, ideas for future classes, if this was helpful and you wanted to expand on anything in particular, please let us know. Itzel will provide all of the contact information. Thanks, everyone. Go ahead.
Thank you so much, Jennifer and Andy. Just very quickly, if you have any questions about AIA learning units or ICC learning units, or about upcoming trainings or any trainings you're interested in, please drop me an email, put it in the chat. Be on the lookout for the slides, recording, and a survey in your inbox coming up in a couple of days, and just some upcoming classes. Dropping the link to our calendar there. And with that, I'll open the floor up for any questions for Jennifer. And yeah, thank you. Thank you again. Really appreciate everyone who made it today.
Yeah, feel free to unmute if there's anyone still on the line. And otherwise, we will give it just a moment. And I also want to be respectful of everyone's time. And even if it's like, hey, can you go back to a certain slide? I'm happy to do it. Oh, one thing for those of you who are still on the call, when you look at that residential code, you'll note that it does sort of dictate that your roofs have a particular slope to them. And that is because you need to work with the physics of vapor being buoyant, and you want that buoyancy to take place. So you want a high part of your roof. So you want that those vapor ports at the ridge. That is really an important part of it. So that vapor will be buoyant and will make its way to the ridge. And then that ridge venting would be continuous essentially along the ridge, or sufficiently large enough along the ridge. And it's okay to bring that down on some of the hip ridges a couple of feet as well. I see a question. Okay, list the HRVs that are certified. On the California Energy Commission website, okay, we'll put a link for you in that, and they do sort of spell out which of the products are listed, and they give you the actual efficiencies of those units, the CFMs. But typically if you're an energy analyst and you're trying to find that information, go to the CEC website and do a search for it. You'll find it. If you're an architect trying to figure that out, most of the big brands all have their products on that list. And then you can work with your energy analyst or your mechanical engineer to sort of figure out what size you need. And they can give you some feedback on what efficiency you need. In existing houses, is there a way to figure out if there are moisture issues in the absence of obvious mold or moisture? Well, yes and no. So in existing houses, my experience thus far has been, you can find out if there's air infiltration, which often can be a moisture issue problem. And sometimes it means removing drywall and looking at the insulation. So if you've done remodels before, you would take that, drywall off, and you could see that maybe the old fiberglass bad insulation is really dirty and dusty and black. It's not necessarily from mold, but it could be from a lot of dirt, because that's how the airflow is coming through those wall assemblies. You can go up into the attic and snoop around and take a look at that. You can also have a HERS rater come in and do a blower door test, or just a smoke. You could go around with a smoke stick and see where it goes. Existing houses can be very drafty. So first I would do a lot of visual inspection, and you might have to deconstruct things here and there. I hope that helps. It's a little, existing houses can be, everyone's unique. Every house is different. With my own house, I had to start with air sealing the floor. That was the first thing I did because it was going to be almost impossible to deal with air sealing or making my crawl space part of the envelope. And I ended up, for ease of construction, air sealing it from the top. Tore out all the old carpeting and air sealed it all from the top. Made a huge difference. And then from there, I could go around and work on the rest of the house. So I think it's just unique for each situation. Mike has a story, Mike, where he was asked a similar question. He went into the house and he suspected the floor being a problem because it had a diagonal sheathing. And when he peeled back the carpet, underneath the carpet was loaded with mold, and the owners had no idea. And so, yeah, deconstruction. Oh, what did I use for air sealing on the top of the floor sheathing? A sealant, caulking, meant for that purpose. Between the sheets of, I had a plywood subfloor, and I sealed between all the plywood joints, and then I took care of that. And then in my case, I ended up using tile, and so just part of that tile process, air sealed it. Oh, thanks for the comment. Thank you. Thank you, Preston. I appreciate it. And for all of those who enjoyed the presentation, I appreciate that. Thanks for the feedback. And like Andy said, if there's other things, ideas, feel free to reach out to Itzel and let us know. But I think, let's see, we're about 9 minutes after. I have 1 more minute. I could stay on the call if that's okay with Itzel, or if there's any other questions or anyone wants to unmute, feel free. Otherwise, I think we will wrap it up.
Alrighty, sounds good. Thank you, everyone. Have a great rest of your day. Bye.
Thanks, everyone.